A very good morning to one and all. So children, today we are just going to discuss the next topic. In our very first video, we discussed about the Newton's first law of motion, that is the law of inertia. Now today we are just going to start with the second law. But before starting the second law, we will just talk about one important topic, that is momentum. So when we talk about the momentum is basically the product of, momentum is defined by, symbolized by the p term. It is the product of the mass of the object and its velocity. Mass of the object and its velocity. Right? So momentum, the SI unit of momentum is, we can say that for mass that is kg and for velocity it is meter per second. So momentum having the SI unit kg meter per second. Kg meter per second. Right children? So momentum, if we define momentum is defined as the product of the mass and its velocity of the object. Now always remember one point, if object is at rest, that means velocity of object is 0. In that case momentum of object will also be 0, that is m into v, and where v equals to 0, so m into 0, that will be equals to 0. So if object is at rest position, that means velocity of object will equals to 0. In that condition momentum of object will also be 0. Now there are some example of the momentum is basically a person get injured by a moving vehicle or a stone because of the momentum, right? A bullet can kill a person due to its momentum, right? So these all examples are of the momentum, right? Now we will talk about the second law of motion. Second law of motion. Second law of motion. So second law of motion is basically gives us the relationship between force and momentum, that is, that defines the rate of change of momentum is directly proportional to rate of change of momentum is directly proportional to the applied force. Right? So that is the statement of second law of motion. Rate of change of momentum is always directly proportional to the applied force, or we can say applied force is directly proportional to the rate of change of momentum. Right? So how will we get? Very first thing, we are having two terms, rate of change of momentum. Rate, when we calculate the rate of any physical quantity, that is the ratio of that quantity with time. That means if we divide any quantity with time, that gives us the rate of that quantity, right? Change in momentum means the object should have some initial momentum and should have some final momentum. So the condition is that if we are having the object of mass m and it started its journey with some initial velocity u, and after some time it attains the final velocity v. So at initial position, what will be the momentum of the object? The product of the mass and the velocity, that is m into u. And what is the final momentum of the object? The product of the mass and the velocity, that is m into v. That is initial momentum and this is final momentum. So when we calculate change in momentum, that will be equals to the final momentum minus initial momentum, right? That is m into v minus m into u. Right children? Now we will just put all the values in equation, that is rate of change of momentum. So rate of change of momentum will be equals to the final momentum minus initial momentum, m into v minus m into u, and rate, that means divided by the time, is proportional to applied force, suppose it is v. Now when we replace the sign of proportionality, so we will multiply a constant to the right side of the equation, and we will get m into v minus m into u upon time. Right? Now we can just have the equation like F equals to K into mass can be common from the equation, so we can have V minus U upon T. Right? Now this V minus U upon T is the final velocity minus initial velocity upon time. So final velocity minus initial velocity means change in velocity upon time. Change in velocity upon time will gives us the definition of the acceleration. That means this value will gives us the definition of the acceleration. So finally we can place the value in the equation. So we will get F equals to K m into A. Experimentally it is calculated that K is the constant and its value is 1. So we will get F equals to m into A. Right? And this is the mathematical formulation of the force. That means second law of motion gives us the formula to calculate the applied force. Very first law gives us the definition of the force. Second law gives us the mathematical formulation of the force. That means with the help of the second law, with the help of this formula, we can calculate the amount of the force that is applied on the object. Right? Now this is the formula for the force. Now we will just calculate the unit, SI unit. So when we calculate the SI unit, so for mass it will be kg, for acceleration it will be meter per second square, and this multiplication 1 kg meter per second square will gives us the value of the 1 Newton. Right? So 1 Newton will be equals to the 1 kg meter per second square, and this will be the SI unit for the force. Right? So this is all about the second law of motion. So this is all about the second law of motion. Now we will talk about the third law of motion. Third law of motion. Third law of motion is a very simple law. It says that for every reaction, to every action, there is an equal and opposite reaction. Right? That means if we apply a force on any of the object, that means it gives some reaction of that applied force. Right? So always remember one point: when action and reaction are acting on the object, so action and reaction will always act to the two different objects. Right? That means if, for example, if we are pushing a wall, that means force that is applied by our hands gives us the value of action, and the opposite and equal force applied by the wall to our hand will gives us the reaction. Sometimes you can just feel the reaction, and sometimes it is not possible to feel that reaction. We are having some more examples of the third law, that is for walking. So when we are walking on the road, that means we push the road to the back side, and road exert an equal and opposite force on our feet to make us move forward. Right? So that is also the example of the action and reaction, or the Newton's third law. Right? Next, when we fire a gun, firing a gun. Right? So when we fire a gun, it exerts a forward force on the bullet, and bullet exerts some equal and opposite force on the gun which results the recoil of the gun, right? So this is the second example of the Newton's third law, right? And a very important and last example of the Newton's third law, when a sailor jumps forward from the boat, boat moves backward due to the third law of motion, right? So when we jumps forward from the boat, what happens? Somehow boat will move to the backward direction due to the third law of motion. And the third example is when a sailor jumps from the boat. So this is the example of the third law of motion, right children? So this is all about the three laws of motion. Those are very important for the exam purpose, and some of the part is always we are having in exams from these topics, right? So try to do the mathematical formulation of Newton's second law, right? So when you will just solve it to yourself, then you will be able to understand the law, right children? So children, that's all for today. In the next lecture we will talk about some numericals. Those are based on the Newton's second law, and some questions numericals from the momentum, right?